we present ECON, which stands for Explicit Clothed Humans Obtained from Normals. ECON reconstructs detailed 3D humans with clothing from a single image. Existing methods can be grouped into two categories: explicit shape-based and implicit-based approaches. The explicit shape-based approaches struggle with clothing that deviates significantly from the underneath body. Implicit-based approaches like PIFUHD introduce pixel-aligned implicit functions, which significantly improve the geometric details and generalize to arbitrary topologies. However, they often produce degenerate shapes for unseen poses. This limitation can be minimized by introducing the 3D body prior as presented in PaMIR and ECON. But this reduces topological flexibility, causing artifacts for loose clothing. ECON is the best of both worlds. It keeps the robustness of explicit shape models for unseen poses without sacrificing the topological flexibility of implicit models for loose clothing. ECON solves this problem in 3 steps. First, given a single input image, it infers detailed 2D normal maps for the front and back sides of the person. Next, guided by simple X estimate of the underlying body, the normal maps are converted into detailed yet incomplete 2.5D front and back surfaces. It then in-paints the missing geometry between two surfaces to obtain the final complete 3D human mesh. Finally, if the face or hands are noisy, they can optionally be replaced with those from SMPL-X, which has a cleaner geometry. Here are some comparisons between ECON and other state-of-the-art approaches. ECON can reconstruct clothed 3D humans from fashion images, regardless of the outfit, yet with more detailed wrinkles than PIFUHD. And for humans with unseen poses, where PIFUHD often fails, ECON recovers high-quality 3D humans as well. The local details look more realistic than PaMIR or ECON. For images with both challenging poses and loose clothing, ECON reconstructs dressed 3D humans with greater realism and robustness than all previous methods by a large margin. One possible use of ECON would be to augment 2D human datasets, such as SHHQ, by producing pseudo-3D ground truth for downstream applications. For example, for learning human pose regressors or generative 3D avatars. We leave this for future work. Due to its ability to complete shapes, ECON can be applied to partial images, where it in-paints the missing geometry in 3D space. This ability is important because it means that ECON can be applied to multi-person images with occlusion. Note that ECON was not explicitly trained for multi-person cases, yet it can cope with this. In summary, we present ECON, a method to reconstruct detailed clothed 3D humans from a color image. ECON combines the best of explicit parametric models and deep implicit functions, which makes it robust even for loose clothing or challenging poses. Please check our paper for more details. Our models and code will be available for research purposes. Thank you for watching.